Okay, this question number 2 is about a weak acid. Write an expression for the Ka of a weak acid Ha in terms of the concentration of the species involved. So the important thing is you need to underline this. This is a weak acid. So what is the expression for Ka? You will write. It is very simple, but I would like an equation for Ha, which is weak acid, H plus and A minus. And when writing Ka, H plus, A minus, divided by Ha. So this is the expression of Ka. Now the second part, the hydroxyl ammonium ion is weak acid. Again, the noticeable thing is we are talking about weak acid. And what is this? This is hydroxyl ammonium ion. We are provided by the concentration of the solution of hydroxyl ammonium ion. And another thing is we are provided by pH. So the first thing first, you need to write the expression for Ka. And for this, you need to write the ionization of HONH3 plus changes to HONH2 plus H plus. So what is the expression for Ka? Ka is equal to H plus HONH2 and it's divided by HONH3 plus. So this is your expression for Ka. And you know, the most important assumption in weak acid, we consider that hydrogen ion concentration and HONH2 concentration, they are equal. So by just modifying this expression, since they are equal to each other, we just put H plus, and it is equal to HONH3. So this expression further modified into, you can write it in this manner: Ka H plus square divided by HONH3 plus so you are left with this. Now you need to put hydrogen ion concentration. You already have HONH3 concentration. So you have the concentration of HONH3, which is given 1.0 into 10 raised to power minus 3 mole per dm cube. But you need to calculate hydrogen ion concentration. So in order to calculate hydrogen ion concentration, very simple thing, you are provided with pH. As you know, pH is equal to negative log of hydrogen ion concentration, right? So by putting pH, which is 4.41, negative log H plus, this expression further modify into C. So by taking antilog in the calculator, you get hydrogen ion concentration, which is 3.9 into 10 raised to power minus 5, right? So now next part of the question, Ka. Now you are going to calculate the Ka, as you already write the expression for Ka. For the weak acid, it's H plus square divided by concentration of HONH3 plus. So you can see 3.9 into 10 raised to power minus 5 square divided by 1.0 into 10 raised to power minus 3, which is the concentration of hydroxyl ammonium ion, which is HONH3 plus. Now by solving this, you get your answer Ka of the reaction, which is 1.5 into 10 raised to power minus 6. Okay, this part of the question, second part of the question, calculate the pK of HONH3 plus, as we have already calculated Ka, and pKa, as you know, pK is equal to negative log of Ka. So very simple, just put the value of Ka here. Your Ka value is 1.5 into 10 raised to power minus 6. So the pKa, you will get pKa, which is 5.82. Okay, this is the third part and last part of the question. And before solving this question, I would like to differentiate between two terms. One is solubility product and other one is a solubility. Now, you know, solubility is totally different term and solubility product is a different term, and student often mix them together, and I want you to learn it clearly. Solubility is defined as the maximum amount of solute that can be dissolved in a solvent. It's a maximum amount of solute that can be dissolved in a solvent. So it is like amount dissolved in a given solvent. So amount can be measured in gram, amount can be measured in mole. So solubility have both these units, like mole per dm cube and gram per dm cube. Now solubility product is also known as equilibrium constant, and equilibrium constant, it describes the equilibrium between solid and its constituent time, right? So they are different. At this KSP is temperature dependent, and this KSP has a different unit, vary for different different for different salts, right? Now coming back to the question, I always recommend student, please do write the equation and write the expression first. It will always help you to solve your question smoothly. Okay, now you get Mn2 plus and 2OH minus, and you know that Ksp is equal to Mn2 plus OH minus square. Now you need to calculate solubility. It means you need to know the dissolved part. Dissolved part are these ions, concentration of magnesium ion and concentration of hydroxide ion. But you don't know about the concentration of magnesium and hydroxide ion. So let's suppose if magnesium is X, it is 2X. Okay, so by just putting these value in the given equation, first put the Ksp, it is given here, see its unit is different, 1.1 into 10 raised to power minus 11, and Mn2 plus, you suppose it X, and hydroxide ion is 2X raised to the power 2, and when you solve it, it becomes 4x square into x 1.1 into 10 raised to power minus 11 and see, it will become 4x cube 1.1 into 10 raised to power minus 11 and x cube 1.1 into 10 raised to power minus 11 divided by 4 and by taking cube root of both sides, you will get the value of x, which is 1.4 into 10 raised to power minus 4. And that's it. You calculate the solubility of magnesium is 1.4 into 10 raised to power minus 4, and if you are talking about hydroxide ion, then it will be multiplied by 2. But here they just ask for solubility, so we calculated it. It is x. Thank you very much. Hope you understand this question. If you have any kind of query, please do ask your question in the comment section. I will answer individually. Thank you very much.